All right, let's get into the most exciting piece of memory when it comes to agents, which is teaching you how you can actually persist memories, pieces of information, whatever you want to call them, to an actual vector database. So, I want to talk about a couple things to start here. Something I want to talk about just off the jump here is one of the questions I get a lot is, do I need to use a vector database? And the answer to that question is fairly complex, but I'm going to try and simplify it as much as I can. And what I want to do is basically address the vast majority of you. And when I say vast majority, I literally mean like 99% of you are only going to need a Postgres database with a vector column. Okay, so one of the things that Postgres has, and this is the advantage of being open source, is that many community members have tried to figure out, okay, how can we take the capabilities of a traditional vector database and how can we add some sort of a column type inside of Postgres, inside of this, database that is, arguably the most popular in the entire world, so that people can use this without having to change their entire tech stack, right? Like, how do we bring sort of this new AI column type, if you will, into this database, right? And the open source community has come up with this thing called PG Vector. And again, I don't want to get overly technical here because I think that starts to make people lose interest a little bit and get a little bit lost. But what I want to emphasize here is that if you see some of these really expensive, and this is one of the big problems with them is they're just super expensive, like a Pinecone, which are totally fine companies and they make good technology. It's just it tends to be a bit overkill for what you actually need. So what we're going to be doing in this lesson and really throughout not just this entire course, but across all of Takeoff, anytime that we use something that needs long-term memory in a database, is we're going to be using SQL. We're going to be using a Postgres database, a SQL database, and we're just going to be using something that is this vector extension. Okay, so you can see I showed this in an earlier video, but all we really need to do to get this to work is that when you create your new table, is you have to make sure that you're using a Postgres provider that allows for using the vector extension here, which in this course we're going to be using Supabase. This is what we use all across Takeoff. I use this in my own projects, and Supabase is just a really easy way to get started with a Postgres database. And so you just need to enable that extension here, and I have this code written for you, so you don't even need to worry about this right now. It's going to be super easy for you to follow along. And what you're going to need to do is you will add a new column that is an embedding column that is of type vector. Okay, you can technically name this anything you want, but typically the standard is to name this column embedding or embeddings. This is going to be of type vector, and then you have to give it the number of floating point numbers, basically, that you're going to be using here, which to keep things inexpensive, we're going to be using, if I go to this helper function here, this generate embedding function I've written so that you don't have to do this yourself, is we're going to be using OpenAI's text embedding 3 small model with 256 dimensions here. And this is basically just the smallest, cheapest, fastest embedding that you can possibly generate via OpenAI. The great thing is embeddings are super cheap, so they're not anything near the kind of the cost of running a traditional LLM, which is super nice because you can literally embed like thousands of pages of text for pennies, which is absolutely incredible. So you don't really need to think about costs too much unless you're building like a super scaled out production grade system. But the point here is that we're going to be using a Postgres database with this vector column, and this is basically going to allow you to just use AI features anywhere you want, because most of you probably come from using some sort of a relational database like SQL. And so we're just going to be using that across the entire course, because especially if you're like somebody who's come from our app course or whatever, right? This is the same tech stack that we use for that, right? So as you get into building applications and agents and all that stuff, every single thing that we teach you here is going to be very industry standard, best practice, and it's going to kind of fall totally in line with everything we're doing. So sorry to kind of give you a little bit of a bogged down technical discussion there, but there's just a couple of points there that I do think are important to know about. And so the things that you just want to take away is that you can use the AI features with your existing tech stack. It's going to be highly performant. It's going to be cheap. It's going to be fast. And it's going to be able to scale well in the event that you ever run into an awesome opportunity, which is that you start getting a lot of users for your agent or something, or you have a really big team or whatever. Everything's going to scale really great. So all that being said, let's actually jump into the long-term SQL file here in memory. Okay, this is going to be the last lesson for memory, and we can actually talk more about integrating our kind of paradigm that we've been using throughout all these other lessons, but take advantage of persisting this to a live database. So what I want to do is I just want to point out some of the differences between this file, this program, and some of the ones we've been running previously. So previously in the last two videos, we've been going over kind of the notepad function. We've actually changed our function calls here. So I just want to cover those really quick. So the tweak that we've made here is that instead of having one function call now, we actually have two function calls, which is we have a getter and we have a setter. Okay, so let me undo that really quick. So we have a function to get memory. Okay, so you can see we've kind of changed the schema to let the AI know, hey, anytime you need to get access to long-term memories, you have the ability to run this function. This is going to call the database, and it's actually going to get results from the database. Okay, awesome. And then we have the inverse of that, right, which is going to be saving memories. So instead of getting memories, this is going to be writing. Okay, so in SQL terms, if you come from a SQL background, right, this is going to be an insert. This is going to be a get, or this is going to be a select rather. And so instead of having just kind of one function, we're actually going to need two functions, because when we get to things like long-term memory, what you really want is you want to selectively grab from the memories, right? Because the idea with long-term memory is you may have some sort of a table that has like thousands and thousands of memories, right? Maybe you built your own AI chat application with some sort of agent with memory that kind of across every single time you've ever chatted with it, it's like storing and saving a bunch of different memories, right? And in that case, you're not going to want to retrieve every single one of those memories. You're just going to want to retrieve the memories that are most similar, right? And the great thing is if we're using embeddings and we're using the vector column here, and we're doing things like cosine similarity search, which we're going to cover in just a little bit here, you're going to get all that out of the box, and it's going to be great. So that's the only real change we've made, is that we're now having to handle those two function calls as opposed to the single function call. And what you'll see here is the memory retrieval will be logged in blue, and then saved memories will be logged in green. Okay, so what I want to show you here first is just this actual long-term SQL memory file working, and then we'll kind of go backwards and I'll show you how to actually set it up yourself. So what I'm going to do here, and again, this isn't going to work for you because we haven't gone over the setup steps. I just want to show you how it works really quick. If I say hi, okay, you're going to see, hello, how can I assist you today? And I'm going to say, what is my name? You're going to see it retrieved memories, okay? Again, retrieving memories in blue, and it got two memories. It got user's name is McKay, and McKay's favorite food is pizza. So what's really cool here is I actually have a table here with two memories in it, okay? So this is where the LLM pulled those memories for, not from some sort of a notepad text file, but this is actually, a production database. You can see I have embeddings here for each one of these. We have some content here. So the idea is that anytime the agent deems it necessary based on the instructions, and again, we're using kind of that personal, if I find the system prompt here, right, you can see use memories to keep track of information about the user. Right, that's going to be when it knows how to call the memory, right? So if I say something like, I live in Hawaii, right, it's going to, in green, hopefully, okay, great, in green, it's going to save a new memory. And what you have to remember again is when you see that green, okay, it used the save memory function, okay, so it called this function, and what that function is actually doing is if we go down here to this if else statement here, what it's actually doing is it's generating an embedding based on the text from that function, okay? What it's doing is it's then inserting that into the database, and just like that, you'll see we have users, you'll see McKay lives in Hawaii, okay? So now, if we stop this chat here, if I do Control C, run this again and say, where do I live? It's going to be able to go do a retrieval, so we should see in blue, it's going to grab those three memories, and it's going to say, you live in Hawaii. Okay, so very cool. We're basically able to have getters and setters to this production database to store memories, which is super cool, right? So the idea here is you could chat, over the course of a year with this agent, and it would slowly start to learn more and more about you, and it would save these things, and you would be able to retrieve the most relevant information and use that however you need, right? So, super cool example. How do you get it to work? So let's actually go over that. So what you need to be aware of here in this project is a couple things. To start here, you'll remember way back when I said don't worry about database URL. This is the time when you need to worry about database URL, okay? So what you're going to do, and the great thing about Takeoff is that we already have videos in the app building section. So if we literally go into courses here, we go over to where is our app building course here. You'll see that we have a backend section here on the tech stack, and we have things like backend setup, and we have things like backend work. All those 3 videos here in this course cover things like Supabase and how to set databases up. So if you want to go more in depth on that kind of stuff, if you're unfamiliar, we have kind of like an entire course that covers our whole tech stack and how to build apps. And we have those backend videos that use Supabase, that use these tables, that use these same setup steps. So if you want to do a deeper dive, go check that out. That's the great thing, right? Is all these different courses that we have on Takeoff kind of come together, and you can kind of build a really solid foundation and kind of cross-reference things as you need. Okay, so super useful resource for you. We're still going to go over that kind of from scratch just to show you how you can get started. So what you need to do is you need to go to supabase.com, and really you can use any Postgres database you want. That's the great thing of how we've set up the tech stack here. On Takeoff, we use something called Drizzle that is fairly database provider agnostic as long as you're using Postgres, which is great. But this is just the easiest way to do it. It has a free tier that you can start using. And so one of the things that you're going to need to do is you're actually going to need to create a new project. So I'm going to go to home here. And what I actually want to do is I want to go to Takeoff projects here. And I want to go to all projects here, and I want to go to new project. And what I'm going to do here is I'm going to call this like memory bot. Okay, you need to generate a password. You can set one manually. I just like to use a generated one. Copy that. Okay, and what you're going to want to do is you're just going to want to copy this somewhere in your env file so you have that password to refer to in a sec. And you're going to want to create a new project. So on Supabase, this is going to go set up a Postgres database for you. You'll see this spinner here that's setting up your project. You're just going to kind of sit here. This can take up to, anywhere from like 2 to 5 minutes, depending on how long the setup takes and what settings you kind of configured based on the compute size that you may have figured, or your server region or what have you there. So what you're going to want to do is you're just going to want to wait for that to set up. So I'm just going to sit here for a sec and come back once this is finalized. Okay, so it looks like we're all good to go. One of the things that you can do is go into the bottom left here, into your project settings, and you're going to want to go to database. So once you go to this database tab here in your settings, you're going to see you have this connection string under this URI. What you're going to want to do is at the very top here, you're going to want to copy that value, and you're going to want to paste that as the value for your database URL. But you'll notice you have this one little area here which says your password. This is where you're going to want to cut the password that you copied earlier here, and you're going to want to paste it right where your password is with the brackets, and then you're going to save it. Once you have this, you will have a database that's all ready to roll that Supabase has set up for you. You'll notice that if you go to your table editor over here, and by the way, just one thing really quick, if for some reason you forget your password, you can always reset that. So if you somehow lost that value, don't worry, you can hit that button and get a new one. But you'll notice we don't have any tables, okay? That's fully expected. Again, I told you this before, but I actually went ahead and I wrote this SQL code for you, okay? So you're not going to need to actually worry about anything right now. What you will need to do is you're going to need to do one thing, which is you're going to, in your terminal here, you're going to need to run npm run db:/migrate, okay? What this is going to do is this is going to go into your package.json and run this npx drizzlekit migrate script. And what this is going to do is going to take the SQL file that, again, I already wrote this, so you don't need to worry about this, but it's going to take the SQL file and it's going to apply this to the project that you just added via your database URL. So we hit return here. You're going to see this little check. If you didn't get a check here, it means that your database URL is probably incorrect. So just go verify that. But you should hopefully see migrations applied successfully. And then if you go to your table editor, you'll see you now have a memories table. Okay. So at this point, what you should be able to do is you should be able to go to your long-term SQL file here. Okay. Copy the relative path, just like we've been doing. TSX space, paste that in. And if I say, I live on Mars, we should hopefully see a green set new memory, and that should hopefully be persisting to the database. So that is how to get everything set up with this particular project. We'll go over how to do this from scratch again in future sections when we start doing more project-based things in kind of more real-world use cases and building agents from scratch. But for the purpose of just kind of teaching you memory and kind of going over the basics so that you're familiar, this is really all you need to know. And you should have everything at this point that you need, again, to actually run this. So what I'm going to do is I'm going to run a few different things here. I'm going to say my favorite food is tacos. Okay, we want to add like 3 or 4 memories here. I want to say my favorite song is, okay, the top song in the world right now is apparently called 25. I've never heard it, to be honest. Okay, so my favorite song is 25. Let's say my favorite movie, SpaceX just had a rocket launch. Let's do my favorite movie is Inception. Okay, so we should hopefully have 4 memories persisted here. So one of the things that I want to show you is to kind of go back to what I was saying earlier, how when you have like 1,000 memories in here, you're not going to want to retrieve every single one of these, because the way this is getting retrieved, right, if you have 1,000 different memories, it will suddenly, you're probably going to have a ton more tokens of memory usage in your context than you really want or need. So one of the things that you can do with how kind of vector stores work and how embedding based search works is if we go to this helper function here, you'll see that we have a retrieve memories function here. Okay, so we're using the retrieve memories function, and this is how we're actually calling the code to go ahead and query our database on this particular table. And you'll see one of the parameters that we have to that function is this limit. Okay, so this is one of the things that you're going to want to get familiar with as you're building agentic applications, is that part of kind of the way you need to tune these things, right? And some of the knobs you need to adjust and the levers you need to flip and all this stuff is you need to figure out how many memories you actually want to retrieve, right? So in this case, I asked 4 different questions. None of these really have overlap. They're all kind of like small little facts about myself that aren't like actually real. Or just making them. Obviously, I don't live on Mars. Just in case you didn't realize that. So if we actually go search for the retrieve memories function here, one of the things that we could do here is we could pass a second argument to this function that's 1. And so what's going to happen here is now, instead of limiting it to the default of 10 memories, we're just going to get 1 memory. So now if I do something like, say, let's restart this chat, and we're going to say, what's my favorite movie? You're going to see we get my favorite movie is Inception, okay? And the way this worked, okay, and this is what's so cool about how these vector stores work, is the way we went ahead and performed the search over our memories was that we computed the embedding for our query, okay? So when we run the retrieve memories function, we're passing in a query, okay? This is whatever our user message was. In this case, it was what's my favorite movie. We generate an embedding for this, okay? And again, we're just using OpenAI's embedding model to do this. This is the same way that we store all of our memories. And what we're doing is we're calculating what's called cosine similarity, which is, we won't get into the technical details of that. But what we're doing is we're basically comparing the embedding, okay, the series of numbers that we got that sort of represents in number form kind of semantically what the text means. and we're computing that against the embeddings in our database. Okay, so in this case, we're computing it against these 4 different values here, and we're trying to figure out what the most similar value is. Okay, and in this case, what my favorite movie turned out of all of these, whatever it was most similar to ended up being the user's favorite movie, Inception, right? Which makes sense, right? That was obviously the correct result, and that was a pretty easy one to figure out. So if I said, like, what's my favorite food and my favorite song here, this is going to get a little trickier because, and you'll see I have like a really slight bug there. And that's because I'm doing iterative function calling, which I probably should fix here. But you'll see here, the first memory we were trying to retrieve was user's favorite food is tacos, right? So the problem with asking 2 questions here, if we're only allowed to retrieve 1 memory at a time, means that we're probably not going to get an answer to the second one. And this is going to be a little bit dependent on whatever the actual embedding similarity calculation was. So the reason I bring up this particular example is because when you're actually building agents in production, 1 memory or 1 reference, right? Like one of the ways, it's not always going to be memories. We're obviously using memories for this example, but say your company or something has a bunch of like onboarding documents or something that's like stored in Google Drive, maybe you have like 25 different docs, and maybe what you're doing in the particular agent that you're building is you're trying to take whatever the user's query is with some sort of like onboarding bot, and you're trying to match their query with like the most relevant doc from all of those documentations, right? Or maybe the 3 most relevant or something, and you're trying to take those and formulate an answer based on the question or something, right? So one of the things that you're going to have to get good at is figuring out how many things do you actually want to fetch from your database. Do you only want to fetch the most similar one? Does that make sense for your queries? Does that make sense to retrieve a bunch of different things? How is that going to affect the speed of response you get? How is that going to affect things like the cost of your response, right? Obviously, the more, records that you're injecting from your table here, obviously you're going to be using more tokens, and that's going to make your bill go up, right? So juggling not just how the quality of your actual retrieval, right, and the quality of how these things come back as being ranked, but how high, how many results you want and things like that or something. Those are all different kind of variables that you kind of need to take into account when you're building agents. So at this point, I think you have hopefully a good grasp of how to actually build a vector store inside of a Postgres database so that you can take advantage of all these awesome features. We're going to be in about a week and a half, we're going to have a separate RAG course. So RAG is retrieval augmented generation, right? This is all the retrieval stuff. We're going to be getting way more in depth on kind of the concepts that I was bringing up at the end of this video, right? In terms of things like managing costs and managing retrieval results, and how do you get better quality results and things like that. So we'll have a separate course because that goes a little bit beyond the scope of what we want to cover here. But this is one of the most powerful things that you can have for agents, right? Long-term memory is a super important paradigm. And if you take away one thing from this section, make sure you take away everything that we talked about in this section, because long-term memory is really what differentiates bad agents from good agents, especially as you use them over time.